Good day. So in this lecture, we will discuss about Python programming. So this is excerpted from Fundamentals of Python, first program, second edition by Kenneth Lambert, copyright C Engage. So for the contents, we have Introduction to Python Programming. We will discuss how to run codes, input, processing, and output, some data types, expressions, functions, and modules. So, in the early 1990s, we have Guido van Rossum who invented the Python programming language. So it's a high-level, general-purpose programming language for solving problems on modern computer system. Actually, if a word from the grapevine, if you are a techie-savvy individual, so we have Python is known as beginner-friendly programming language. So you can look up more information about Python on their website, www.python.org. So, Python is an interpreted language. So, a simple Python expression and statements can be run in what you call a shell. So, most of the time, for example, in Windows, when you install Python, you have the idle shell. Although you can use other shells. In here, I'm using a combination of idle. Sometimes I use idle, sometimes I use atom.io, and sometimes I use spider. So for this lecture, I will show you. I am using spider, though I'm not saying that you should limit yourselves to those three or use all three. You can just choose one, and actually you are free to do whatever you want, what shell you wanted to use. Okay, so why do we use a shell? So a shell is useful for experimenting with short expressions or statements or consulting the documentation. So this is an example of a Python shell window. This is from Mac. So that's a Python shell. So it's just a simple, it's like a command line or a terminal window if you're more used to Linux. So, in input processing and output, so programs usually accept inputs from a source, process them, and output results in a destination. So basically, that's the basic, programming. So in a terminal-based interactive programs, these are the keyboard and terminal display. So in Python, the inputs are the Python expressions or statements, and we have outputs that are usually displayed in the shell. So programmers can force output of a value by using the print function. So if you want to show the output, so you just write print, open and close parentheses, and your expression. By the way, this is one of the differences in Python 2 and Python 3. Print in Python 2 does not have open and close parentheses, but Python 3 requires the open and close parentheses. So for example here, the universal example, print hello world. So we have print, which is your basically a Python command. By the way, Python, there are several Python commands, and these you cannot use these commands as variables. So these are already reserved words. Basically, they call them the reserved words. Okay, and you have hello world and close in single quotation marks, so to designate that this is a string. So the input is basically your command, and it shows you, or it prints the expression hello world. So another example, so the thing you are seeing here is the interface using idle, by the way. So as you can see, you have the triple greater than sign that that designates basically in idle. This is the console for idle. So I want to input the name in a variable name. So the variable which will contain the information which you will input. So by the way, input is another reserved words for command. So it prompts you to type in a value. So for example, input, enter your name. So the enter your name will be shown. So if you have, for example, actually, let's look it. Let's look this up in the actual Python consoles. So let me switch. Okay, so this is your Python console. So we have name. So this is the console. By the way, this is the Python, sorry, Spider uh, interface. So you have here, pakita ko na agad, um, a Python script, an example of a Python script. So I have several examples. We will discuss this one. But let's look at the example. For example, name. I want to input the name. Rather, I will assign the input in the variable name. So input, enter your name. So enter my name. So let's say Marinil. Okay. And then the next one is I wanted to print the name. So we have print, open and close, name. Now I do not need to enclose this one in the parentheses unlike in the hello world a while ago, because name is a variable, not a string. So it outputs my name. By the way, as you can see, this is spider, not idle. So you have a different prompt. So instead of the 3 greater than sign, it's in 5. So basically, it's the number of lines. I have been using some commands, so that's I'm on line 5. So 5, 6, and then I'm now on line 7. Now let's go back to the presentation. Okay, so this is the example of that. Okay, so the invert function always builds a string from the user's keystrokes that returns the program. So you have conversion factor. So we have two main types, although the data types are not limited to these, but two main types. You have, especially for numerical data, you have integers and float. So integers, int, basically they are whole numbers, and you have the floats, the floating point numbers, having decimal points. So this is a Python command that converts whatever you input into an integer value. So in here, you input a number, 33, and then another number, which is 44. So it will add the sum of, well, basically, the first plus the second. So it will output you with the sum of your first and second input. So basically, you have here several functions. So when you say float, so a float converts a string of digits to a floating point value. So usually we have a string. So in the previous example in here, the enter your name input, it gives us a string. So whether you input there a number or alphanumeric symbols, it is always considered a string. So you cannot perform arithmetic operations in a string unless you convert your string into a float or integer value. So these are some. Okay, so we usually run Python program files or scripts within the idle or in the OS, your operating system's command prompt. So basically this is your idle. So let me show you. So this is your Python script in an idle. So I'll show you my script from here. Okay, so I have here the Python file. For example, this is, it's a Python file because it has the extension code.py. So this beer oiler.py. So this is the syntax. This is my program. So I have here numpy and matplotlib. So these are packages that each package in Python, or because Python is a modular type of language, so these are um, uh, modules that allows us to perform specific commands. For example, numpy gives us additional functions to to actually create arrays and matrices. And then we have matplotlib. It's usually used for plotting. Okay, so in here, in my program, I have import. Import is the command in Python that allows us to import the specific package. So this I'm importing here numpy and matplotlib. Now, using the numpy command, because normally in the intrinsic or the basic Python command, it cannot generate arrays. So I have an array of the range 0 to 2000.2 with intervals of 0.2. So I have n, which is the length of my t. So this is another variable, the dt 0.2. So these are my array. I generated an array. By the way, if you want to have comments in your Python script, so you have your sharp sign. This denotes comments. So I tend to use this one so that I won't get lost within my codes. And then another comment. So these are my parameter constants. V, K1, KP, KM. So we have another note for myself. So generating arrays consisting of only one. So NP, again, from the module numpy. So this will generate me an array mostly consisting of number 1. The contents of the array is the integer, rather the float 1. We have another array G. And I set up initial values. The first, this denotes that the ATP 0, so from the array ATP, the first digit is changed. So from 1, it's changed to 4, and then the same goes for G, it's changed to 3. And then I have a loop structure. So we will discuss a loop in the next lecture, but anyway, this is my loop structure. So I have my calculation command here, and then this is PLT figure. So this chunk here is the command for showing the plot for, or rather graphing the outputs of this of my code. So let's try to run this one. So running the file. So this gives me this particular output. So this is my command line beside here, and this is my this is the output using matplotlib. So this is an oscillating output. So let's look at another program. So again, numpys and matplotlib. So I have several integers here. It's actually longer than the previous one. So this is from a previous study about binding models. So I have defined variables. So first of all, of course, I import the needed modules, and then I define the variables, and then describe or get the calculations for each particular variables, and then I generated an array of values, and then I describe the different calculations or values for that, and then another round of values, so on and so forth. And then I have here the figure or the plotting. So in here I have the calculations, but without this chunk here, we won't be able to see the results of the calculation. So in Python, you need to specify in your code the results. And so let's run this code. Okay, so this is the result of that curve. So we have your label. So what is 1 minus y? So we have one substrate cut. So this is from x, and 1 minus y. Where is 1 minus y? y1. Okay, so this is y1, y2, y6. Oh, it's supposed to be y3, 4, 5. Okay, so this is a different one. I didn't show this one. So I have 3, 4, and 5. So these are my the results of that. So the y values, so they actually printed out this curve or line. And then what are the blue dots? The blue dots are Actually, these are from data. It's not exactly an array, but uh, well, basically an array of data. So I have another label of that. So these are specific value points. So anyway, that's the basic of what you can see or expect in your Python file. So let's move back the presentation. Okay, so in how Python works, so you have your code, so it can be run line by line from the console, or you can write your code in an editor. Usually it's a text editor. A text editor can actually work. Notepad, Notepad++, text editor, atom.io. So you can do whatever. You can write it as long as your extension is .py, and then it will run into a syntax checker and a translator. So it first check if there are any syntax errors, and it actually outputs us. If there are any, it will give us immediately which line and what type of syntax error it is. That is why Python is beginner friendly. And then it will run the code. And if you are requiring additional inputs, so you will also input additional information, and then it will give outputs or some other error message if there are any issues with your input. So programmers inevitably make typo errors when editing your programs, and these are your syntax error. So the Python interpreter will usually detect these syntax errors. So when a Python encounters a syntax error in a program, it halts execution with an error message. So for example, the original file is, for example, you're going to input a length. So I input it as 44. So this changed the value to 4. And then you input another command, print in length, but I forgot to write G. So it will, this is from the spider. So it will trace it back where the problem is, and it will tell me in line 1, because this is the first line in the most recent command, insert the module, the problem is print length. So the type of error, your length is not defined. So let's try it with my code. So let's go back to our spider. Okay. So let's see. Let's just use this one, which is shorter. So let's say that I had I won't define a certain value. For example, I'll just remove 2 here, f times d. So there are no other f here, so let's try. So here you can see there's a problem here. So where are we? Okay, so name error, f is not defined. So since we do not define the variable f anywhere, so it gives us an error immediately. And since it's inside the loop, we have several run file problems or issues. So let's look at other samples. So how about I change this one to G O. Okay, and then let's try to run. Oh, actually it runs because it generated an array of 3, but since it's just a single data array, it gives us this type of plot. So these are some errors that you encounter. How about this one? Let's change this one to K1 and then run the program. So they have, what is this? We have K1 pala. Let's change the value. Okay, sorry. It's not supposed to be K1. Wait, what's this supposed to be? Kn. Okay, let's try Kn. And then it gives us, where's Kn? Nawala si Kn. Okay, so it gives us another different value. So this is M. Hmm, it won't. Okay, anyway, those are for some problems. How about this one? NTRH. Let's try to run. So attribute error has no attribute. So that means you have a problem in the command. There is no rh command because you forgot n. Okay, so that is the gist of our Python when we have problems, issues with the code. Okay, so since this ones involves numerical values, so it's not usually the syntax error from that one. But anyway, let's go back to our presentation. Okay, so we have this type of errors. Now another example. So what if we have incomplete expressions? So again, it will give us a value, invalid syntax. Then data types. So data types consist of the set of values and a set of operations that can be performed on these values. So literal is the way the value of a data looks to a programmer. So int and float are numerical data types and they represent numbers. So you have here integers. We have the different types of data: integers, real numbers, and characters. So integers are whole numbered values. We have the floats, which have decimal points, and this is one of the main contentions between Python 2 and Python 3, because if you have, since both of them are numerical data, you can perform arithmetic expressions here. But if you have an integer and a float in a single expression, Python 2 automatically converts your float to the integer, which gives you inaccurate results. Unlike for Python 3, it will change the integer to float, and you will have a more accurate result. That is also one of the reasons why I asked you to specifically to install Python 3. Okay, and then we have character strings, usually enclosed in quotation marks. So in Python, a string literal is a sequence of characters enclosed in single or double quotation marks. So for example, here is another example of the use of these quotation marks. So for example, I am using another quotation mark inside my string. So I use a double quotation mark here to separate it from the single quotation mark within the string. So I can use double quotation marks, or you can just use single quotation mark. So what if I use single quotation marks if I have another single quotation mark inside my string? So since you started with a single quotation mark, the next quotation mark is the automatically is read as the end of the initial quotation marks. So you have now a syntax error. So we usually use the triple quotation marks or three quotation marks for multi-line paragraphs if you have a very long document. So we also have variables. So a variable associates a name with a value. So it makes it easy to remember and use later in program. So variable naming rules. So if reserved words cannot be used as variable names. So what are those reserved words? So these are words that specifically means something to Python. For example, print, int, yeah, if, def, import. So those words cannot be used as variable names, because instead of being recognized as a variable by Python, it will be recognized as by its actual use, and you will have an error in your hands. So you can actually know it immediately if you are using either Python or idle or spider, because especially for the commands, if you notice here, you will, even within writing the command, it have would have highlighted as blue automatically. I did not image by itself write it. For example, let's see. def. So automatically it becomes blue. That means it's a reserved word. So Python automatically highlights your text. So we have the reds here as variables, and then we have these are data. So numerical data, and these are our variables. So NP ones, they do not highlight here because this is from the module, not exactly as a reserved word for Python. This is from the NumPy module. That is why I have np dot here. So that means we have the command once specifically from the module numpy, and since I had it as numpy as np, so that I won't have to type numpy, the whole word numpy. So it's just a shortcut. And then another one, matplotlib.pyplot. So we have plt. So any commands within this package matplotlib, so I will call it using plt and then the dots. So for example here, plt and then the command figure 1. So plt.plot. So anyway, that is your Python. The use of modules in Python. So go back to our lecture. So we have the variables. It must begin with a letter or an underscore. So the name can contain any number of digits or letters, but you cannot start a variable with a number. So you need to start it with a letter or your underscore. So another thing is the variable names are case sensitive. So you need to know, you need to be careful. For example, you um, capitalize K, and then in the next line you want to use the variable K, but you write it as a small letter. So it's read as a different value. So that is basically some of the variables. So variable serves two purposes. It helps the programmer keep track of data that change over time and allows the programmer to refer to a complex piece of information with a simple name. Okay, so let's discuss program comments and document strings in the next video.